Good day everyone. Today we will continue discussing the applications of derivative, and this will be the outline of our lecture. First, we will define increasing and decreasing functions and use the first derivative in order to find the intervals for which a function is increasing and decreasing. Second, we will define the relative and absolute extrema. Here we will present two tests, which is the first derivative test and second derivative test, both of which are used in order to get the extrema of a function. Third, we will define concavity and use the second derivative test to describe the concavity of a graph and also to get the points of inflection. And lastly, we will use all the concepts we've learned from the first three parts in order to sketch a curve. Okay. Now we begin with the intuitive definition of increasing and decreasing functions. Observe muna natin itong graph na to. So from the graph of this, actually nakikita natin kung saan increasing and decreasing ang ating function. Observe muna natin siya sa interval na negative infinity to 0, that is to the left of our y-axis. So ito yung part na yon. So as the graph goes from left here to right to this point, our graph is rising. So pataas yung graph natin from here to here. On the other hand, from 0 to positive infinity, that's to the right of the y-axis, our graph from left here to the right here is falling. And actually, the function is increasing kung kailan siya pataas, so that's at negative infinity to 0, and decreasing kung kailan siya pababa, that's at 0 to positive infinity. And this is the definition of increasing and decreasing functions. So if we have a function f, it is increasing on an interval I if for any x sub 1 and x sub 2 in the interval I, then if x sub 1 is less than x sub 2, this implies that f of x sub 1 should also be less than f of x sub 2. And baliktad naman siya for decreasing. It is decreasing on an interval I if for any x sub 1 and x sub 2, if your x sub 1 is less than x sub 2, this implies that f of x sub 1 should be greater than f of x sub 2. Okay? And to illustrate this graphically, so itong first part na to, sabi natin kanina, at 0 to negative infinity to 0, ang ating function ay increasing. So therefore, makikita natin na if x1 is less than x2, then yung y1 natin here ay mas maliit sa ating y2. Okay? You could also think of this as if pinapalaki natin yung value ng x, then dapat tataas din yung value ng y, which is true in this case. So we have that one. x1 less than x2 implies that y1 is less than y2. On the other hand naman, dito sa kabilang graph, sabi natin from 0 to infinity, decreasing siya, which is true because if x1 is less than x2, okay, nakikita natin na yung y1 natin ay mas mataas sa y2. Okay? So y1 greater than y2. And again, pwede natin itong isipin na kada tumataas yung value ng x, lumiliit naman yung value ng ating y. Okay? Now, i-relate natin yung pagiging increasing at decreasing ng ating graph based on the tangent lines. Okay? So, tignan natin dito. At this point, our tangent line has a slope that is positive, right? Taas siya. Same as well as this point and at this point. Okay? So, nakikita natin, if you check, lahat ng points dito, kung saan siya increasing, yung mga tangent lines at that point, lahat sila ay may positive na slope. So we have this observation: when the graph is increasing on an interval I, then for any x in I, the slope of the tangent line at that point is positive. And tignan naman natin dun sa mga points na decreasing siya. This is a top part. Kuha tayo ng isang point, this one. So ang tangent line at that point ay pababa. The slope is negative. Same as well as this point and as this point. So similarly, the graph is decreasing on an interval I if for every x in I, the slope of the tangent line at that point is negative. So observe that the graph is constant on the interval AB. That is because we have a horizontal line. So same lang ang ating y-coordinate for all values of x between A and B. At makikita natin, this is our tangent line, which is also a horizontal line. Okay? And what can we say about the slope of a horizontal line? The slope of a horizontal line is equal to 0. Therefore, at the interval AB, where the graph is neither increasing nor decreasing, that means our graph is a constant, the tangent line is the horizontal line, which has a slope equal to 0. Okay? And so we have this theorem. Let f be differentiable on an interval AB. Okay? Yung first one, yun yung una nating case kanina, ang slope ng tangent line natin kapag increasing ay palaging positive. Pero again, ang slope ay derivative lang at that point. Hence, if f prime of x is greater than 0 for all x in your interval, then f is increasing on that interval. Okay? Similarly, if f prime of x naman is less than 0 for all x in that interval, then f is decreasing on that interval. And yung last observation natin, if our f prime of x is equal to 0 for all x, then f is neither increasing nor decreasing. In that case, f is a constant on our interval. Okay? So this is how you use the first derivative in order to find the intervals for which the function is increasing or decreasing or neither. So we also have this remark: for a continuous function f prime of x can change sign only at x values where f prime of x equals 0 or is undefined. So kung gusto nating malaman kung kailan nag-change ang isang function from increasing or decreasing and vice versa, then ang i-consider lang natin ay yung mga values for which our derivative is 0 or is undefined. And we call these values the critical numbers of f. Okay? So again, the critical numbers are the value of x for which f prime of x equals 0 or is undefined. And let us now use the theorem and the remark in order to find the intervals on which this function f of x equals x cubed minus 3 over 2x squared is increasing or decreasing. So from our theorem, ang pagiging increasing at decreasing ng isang function ay based doon sa signs ng ating f prime. Sabi nga natin, we need to determine the intervals when f prime of x is positive and negative. And to determine these intervals, we have first to find the critical numbers. Kasi nga, dito lang yung may chance na magbago yung signs ng ating f prime of x. Okay? So we get f prime of x first. We have 3x squared by power rule. And then dito baba natin yung 2. That's just 3x. And we get the zeros of this one. So dito wala naman tayong values na magpapa-undefined, right? So yung mga critical ng numbers lang natin ay yung magpapa-0 dito. Equating this to 0, we have this 3x times quantity x minus 1 equals 0. So our zeros here are 0 and 1. So anong ginagawa natin para makita yung signs ng isang function over some intervals? Katulad ng ginawa natin sa rectilinear motion last meeting, we will make a table of signs. So same process lang dun dati. Okay? So take note, we're getting the sign of f prime of x and not f of x. Okay? Because we're just concerned at the sign of the derivative in this case. So ang critical numbers natin ay 0 at 1. So hatiin natin ang buong number line based on that critical numbers. First, we have negative infinity to 0, 0 to 1, and 1 to infinity. So nandito nga yung intervals. And then sa left, kagaya dati, would be the factors of our f prime of x. So sana naalala nyo pa yung technique na tinuro ko doon sa table of signs sa rectilinear motion. If your factor is linear, then kukunin lang natin yung 0. Okay? Ang leading coefficient niya ay positive. So ang 0 ng x ay 0 lang. So everything to the left at this partition is negative. So this is negative. Tapos, doon sa right niya would be positive. So we have positive, positive here. Okay? So x minus 1 naman, the zero of this is 1. So this point. So to the left of that is negative. We have negative, negative. And then to the right of this part is positive. So we have this one. Okay? So again, if you want to double check, you can always test points. So now that we have the signs of the factors, tignan natin ang form nito. This is 3 times x times quantity x minus 1. 3 is positive, it will not affect the sign of your whole f prime of x. So we just look at the sign of the product of these two. So looking at this, we have negative times negative. That's positive. Positive times negative is negative. And positive times positive is positive. Okay? So therefore, kung gusto natin makita kung saan siya increasing, tignan lang natin yung saan siya positive. Okay? Hence, f is increasing on the interval, this one, negative infinity to 0, yun, this part, 1 to infinity, and decreasing at the interval where our f prime is negative, which is at 0, 1. Okay? So, to recap again, para malaman kung saang intervals increasing or decreasing ang isang function, first, we get the derivative, we get the critical numbers. Those are the values of x for which f prime of x equals 0 or is undefined. Then, make a table of signs. So, nasa taas yung intervals na hinati natin based on the critical numbers. Nasa left yung factors ng f prime of x. And then, fill out the table. And finally, f is increasing doon sa may mga positive na sign si f prime and decreasing doon sa may mga negative na sign si f prime.
And now, for the second part, let's start with defining the notion of the relative and absolute extrema. So let f be a function defined as c. First, f of c is called a relative maximum of f if there exists an interval containing c such that for all x in that interval, f of x is less than or equal to f of c. Okay? So ang sinasabi lang nito, ang f of c ay isang relative maximum if ito yung highest y coordinate for some interval of x that contains c, and that interval need not to be the whole domain of f. Okay? Similarly, f of c is a relative minimum of f if there exists an interval containing c such that for all x in that interval, our f of x now is greater than or equal to f of c. So that means this is the lowest point on that interval of x. And now, f of c is an absolute maximum if f of x is less than or equal to f of c for every x in the domain of f. And it's an absolute minimum if f of x is greater than or equal to f of c for every x in an element of domain of f. So, for the absolute extrema, ibig sabihin, siya yung highest or lowest point for the whole domain of our function. So, for relative extrema, ito yung pinakamataas or pinakamababa for some parts of our graph. But for absolute extrema, ito yung pinakamataas or pinakamababa for the whole graph of f. Okay?
Let's illustrate the relative and absolute extrema by observing this graph. We have 3 special points here. Let's start with the first one. So using the definition earlier, we can say that f has a relative minimum at this point because this is the lowest value on this part. Okay? On this part naman, ang f natin has a relative maximum at this point because this is the highest value on this part. Take note na kapag relative maximum, hindi kailangan na siya yung pinakamalaki sa buong graph kahit lang sa isang part lang ng iyong graph. So, for example, from this to this part. Okay? Then, f has a relative minimum at this point naman because this is the smallest value on this part. Hanapin naman natin kung saan may absolute minimum si f. So, we look at the lowest y coordinate. So, saan ba yung pinakamababang point sa ating graph? That would be at this point. So, f has an absolute minimum at this point. Next, yung absolute maximum. Take note, ang choices lang natin for absolute maximum ay yung mga relative maxima natin. And in this case, isa lang ang relative maximum natin, which is at this point. Pero ito ba ang highest point ng ating graph? The answer is no, because if you look, as x approaches negative infinity on the left part, then our function increases without bound. That means f approaches positive infinity. Ganon din sa right, no? As x approaches positive infinity, our f approaches positive infinity. So therefore, at some parts of our graph, ang y natin ay nag-i-increase without bound. It approaches positive infinity. Therefore, we don't have an absolute maximum. Okay? So ito ang summary ng ating observation. So, remark lang that you can have more than one relative maximum and more than one relative minimum. However, you can only have at most one absolute minimum and at most one absolute maximum because that should be unique. That is the highest and the lowest point on your whole graph. And moreover, if at some parts of your graph, your f of x approaches positive infinity, then we don't have an absolute maximum. Similarly, if at some parts of your graph, your f of x approaches negative infinity, then you don't have an absolute minimum. Okay? Now we will present the first derivative test for relative extrema. We can use this test in order to determine all the relative extrema of the graph of our function. We have first this assumption: let f be continuous on the interval AB in which c is the only critical number. If f is differentiable on that interval, except possibly at c, then first, we have that if f prime of x is greater than 0 for x less than c, and f prime of x is less than 0 for x greater than c, then f of c is a relative maximum. So graphically, ganito yung nangyayari. Okay, let's say we have this point, cf of c. Sabi sa 1, for x less than c, that means to the left of c, our f prime of x is greater than 0. That means our f is increasing. So, it could look like this. Okay? And on the other hand, for x greater than c, our f prime of x is negative. That means the graph is decreasing, so it goes down. Okay? So, makikita naman natin that indeed, at this point, you have a relative maximum. Okay? Similarly, for the second one, if your derivative is less than 0 for x less than c, and f prime is positive for x greater than c, then f of c is a relative minimum. Okay. And graphically, let's say this is cf of c. Okay. Sa left niya, we have a negative f prime, therefore decreasing. And then sa right niya, we have a positive f prime, therefore increasing. Hence, indeed, we have a relative minimum at this point. Okay? And lastly, for letter C, if f prime of x is greater than 0 for x in AB such that x not equal to c, and f prime of x is less than 0 for all elements in AB such that x is not equal to c, then f of c is neither a relative maximum nor minimum. Okay? So, isasabi lang ng 3 na kapag hindi nag-change ng sign ang ating f prime from the left of c to the right of c, then it's neither a relative max nor a relative mean. Okay? And also, ulitin lang natin from 1 and 2 na kapag nag-change ang sign natin, then we have a relative extrema. In particular, sa first case natin, if the graph of f changed from increasing to decreasing, that means ang sign ng f prime natin change from positive to negative, then we have a relative max. Okay? At dun nga sa second case, kapag decreasing naman to increasing, that means the sign changed from negative to positive, then we have a relative minimum. Okay? So that is FDT, or the first derivative test for relative extrema. Now we use the FDT for us to find all the relative extrema of this function, f of x equals 2x cubed minus 3x squared minus 36x plus 4. Again, meron tayong relative extrema kapag nag-change ng sign ng ating first derivative. And recall natin, doon sa first part, kailan lang ba possible mag-change ang sign ng first derivative? That will be at the critical numbers. Okay? So we find the critical numbers. We get first f prime of x. That's equals 6x squared minus 6x minus 36. So again, ang critical numbers is kung kailan f of x equals 0 or f of x is undefined, pero this will never be undefined. So kukunin lang natin yung zeros nito. So factoring this out, you have 6 times this expression. And if you factor it furthermore, should be equal to this. And equate nga natin siya sa 0. So we will get two critical numbers here. We have x equals 3 and negative 2. Okay? So again, as I've said, since f prime is defined for all real numbers, then the only critical numbers of f are x equals negative 2 and x equals 3. Okay? And since we want to look at the signs of f prime, we will again make a table of sign. Okay, so may addition lang tayo sa table of signs natin ngayon. We will put additional columns for our critical numbers. In this case, we put a column for negative 2 and 3. And ganun pa rin yung intervals natin. We divide it based on our critical numbers. And madadagdagan din tayo ng isang row. We have here f of x. Okay? So, ang i-fill up lang natin for f of x ay yung functional value ng ating critical numbers. So, we just put here f of negative 2. If you try to plug in, you can verify that that's 58. And here we will put f of 3. And if you try to plug in, that should be negative 67. Okay? Next would be to get the signs of f prime. So we get the signs of the factors. The first factor would be x plus 2. So katulad ng technique natin kanina, 0 siya dito. So sa left niya negative. At negative 2, lalagyan din natin siya. That's a 0. And everything to the right of this is positive. So we have positive, positive, positive. Okay? Next factor is x minus 3. That is at this point. So everything to the left of this will be negative. At this point exactly, this is 0. And to the right, we have positive. Okay? So now we can get the sign of f prime of x. Again, 6 is positive. It will not affect the sign. So just get the sign of the product. Negative times negative, we have positive here. 0 siya sa negative 2. Negative siya dito. 0 and positive times positive is positive. So again, possible lang magkaroon ng relative extrema at the critical number. So i-check natin isa-isa. At negative 2, to the left niya, positive. To the right niya, naging negative. Therefore, nag-change ang sign ng ating f prime. Moreover, kapag positive to negative, that means pataas, then bababa, then we have a relative maximum. Okay? So, using the first derivative test, f of negative 2 equals 58 is a relative maximum. Moreover, at 3 naman, you have negative to positive, so that's pababa to pataas. Then, you have a relative minimum. So, f of 3 equals negative 67 is a relative minimum. Okay? So, just a note, ang relative maximum ay yung 58 at ang relative minimum ay yung negative 67. Hindi yung negative 2 at saka 3. Okay? Next, we do the same for here. We get the relative extrema of x to the 4 minus 4x cubed. So, same process. We get f prime first and the critical numbers. So, f prime is 4x cubed minus 12x squared. Factoring this out, you'll get this. Okay, ang 0 ng x squared ay 0 lang. Ang 0 ng x minus 3 ay 3. Same with earlier, this can never be undefined. So, ito na yung ating critical numbers. And we make the table of signs. We divided it with 0 and 3. First row will be f of x, functional values of our critical numbers. So, that's 0 at x equals 0. And f of 3 is negative 27. So, check nyo na lang yung mga functional values. No? That's just simply substitution. Next is to get the signs of our factors of f prime. The factors are x squared. Okay? So, ang x squared natin, no matter what we put here, this will always be positive, right? Except at x equals 0. Kasi 0 siya nun. It will be 0 here. So, you have positive at all points. So, ito yung sinabi ko last time, yung technique natin will only work for linear factors. Okay, so pag quadratic siya, hindi mag-work yung technique na sinabi ko last time. Okay? And for x minus 3, so linear naman to, we get the 0 at 3, and then everything to the left is negative, and everything to the right is positive. As illustrated in this row. Now that we have the sign of the factors, we get the sign of f prime itself. 4 is positive. Okay? So just take the sign of this one. We have positive times negative, which is negative. It's 0 here. Positive times negative is negative. It's 0 here. And positive times positive is positive. Okay? So actually, kung mapapansin nyo, yung x squared naman positive siya palagi, except nga dun sa magze-0 siya. So, technically, kinopya lang din natin yung signs ng x minus 3 doon sa mga parts na hindi siya nagze-0. Okay? And we check at the critical numbers kung ang f natin ay may relative extrema at that point. At x equals 0, what can you say? Sa left niya, negative. Sa right niya, negative ulit. So, hindi nag-change ng sign. So, therefore, f doesn't have a relative maximum nor a relative minimum at x equals 0. And at 3, you have negative sa left, positive sa right. So, that's pababa, then pataas. Therefore, the only extremum is f of 3 equals negative 27, which is a relative minimum. Okay? Okay, so pwede rin natin gamitin ang second derivative to find the relative extrema. That is what we call the second derivative test for relative extrema. We have this. So suppose f double prime exists on some open interval containing c and f prime of c equals 0. If f double prime of c is greater than 0, then f of c is a relative minimum. If f double prime of c is less than 0, then f of c is a relative maximum. If f double prime of c equals 0, then the test fails. Okay? Illustrate natin paano natin siya ginagamit. Okay? So, find the relative extrema of this function. Same, yung first step, we have to find the values of c such that f prime of c equals 0. So, I will leave this as an exercise. Verify that if you get the zeros of your first derivative, it should be equal to x equals negative 2 and x equals 3. Now that you have the zeros of f prime, pwede mo nang i-check by SDT kung relative extrema siya. So, ang gagawin lang natin, kukunin lang natin yung f double prime at these points. Pero bago yan, kunin mo natin yung f double prime. If you check, that should be 12x minus 6. So, evaluate natin at the critical numbers. F double prime of negative 2 is negative 30. This is less than 0. Okay? Since our f double prime is less than 0, by SDT, f of x has a relative maximum at x equals negative 2. On the other hand, f double prime of 3 is equal to positive 30, which is greater than 0, then f of x as a relative minimum at x equals 3. Okay? So, again, pag nakuha nyo na yung critical numbers, i-substitute nyo sa second derivative. Pag negative, then relative maximum. Pag positive, then relative minimum. Okay? Okay? For example 2, we do the same process. We get the critical numbers. Okay? So, verify nyo na lang din. You verify that the zeros of your first derivative are 0 and 3. Get the second derivative. Okay, ang first derivative nito, 4x cubed minus 12x squared. If you differentiate that once more, you'll get 12x squared minus 24x. Okay? Then, evaluate natin sa second derivative. F double prime of 3, if you check, should be equal to 36, which is positive. So, again, pag positive, we have a relative minimum. Therefore, f of x as a relative minimum at x equals 3. And at x equals 0, f double prime of 0 will be equal to 0. Okay? So, whenever SDT fails, you have to use the FDT for x equals to 0. So, that means you have to observe the sign of f prime of x to the left of 0 and to the right of 0 and see if it changes. Okay? So, yun. For getting the relative extrema, pwede nyong gamitin parehong FDT and SDT. However, yung SDT minsan nag-fail siya. So, if it fails, you have to use FDT. Ngayon naman, dumako tayo sa third part ng ating lecture, which is about concavity. We define it first. Let f be differentiable on an open interval I. Graph of f is concave upward on that interval. If f prime is increasing on the interval, it is concave downward on that interval if f prime is decreasing on that interval. Okay? So let's illustrate that graphically. We begin with this graph. So tignan natin ang slope ng tangent line sa iba't ibang points na to. Ang slope ng tangent line na to ay negative. Ang slope ng tangent line na to ay positive. So, obviously, mas mataas to dito. Itong slope nito ay positive, pero mas malaki ang slope nito dito kasi steeper to dito. So, nakikita natin na ang slope ng tangent lines ay palaki ng palaki. So, ang slope ng tangent line nga ay equal lang sa f prime of x. Hence, f prime is increasing and this graph is concave upward. Similarly, with this graph, meron tayong positive slope, tapos naging 0 at this point, tapos naging negative at this point. Hence, pababa ng pababa yung slope ng tangent line, hence f prime is decreasing, therefore this graph is concave downward. And may isang property pa tayo na mapapansin based on these two graphs. That is, if the curve lies above its tangent line, so, dito yung graph natin, lahat nasa taas siya ng mga tangent lines, then it is concave upward. On the other hand, if the curve lies below its tangent line, then it's concave downward. And pwede nating malaman ang concavity ng ating function based on the second derivative. And take note, if you want f prime to be increasing, that means yung derivative niya should be greater than 0. At ang derivative ng f prime ay f double prime lang. So, we have this alternative definition. If f double prime is greater than 0 for all x in the interval, then the graph of f is concave upward on I. Tapos, ganun din, kung gusto mong f prime is decreasing, that means your f double prime is less than 0. This is that case. If the second derivative is less than 0 on that interval, then the graph of f is concave downward on that interval. So, para ma-check ang concavity ng graph ng f, you just look at the signs of the second derivative. Okay? So, ito yung step-by-step na gagawin natin para malaman kung saang intervals concave upward and concave downward ang ating graph. We first find the second derivative. Locate the values at which f double prime of x equals 0 or undefined. Ito yung tinatawag nating PPOI or possible points of inflection. Parang counterpart siya ng critical numbers sa first derivative. Third, gagamitin natin yung mga PPOIs natin para hatiin yung intervals natin. And lastly, we make a table of sign. Okay? So, very similar process lang siya kanina dun sa pagkuha natin kung saan increasing or decreasing ang isang function. But, in this case, we look at the second derivative. And moreover, so nabanggit ko na kanina pala yung possible point of inflection. And to formally define a point of inflection, doon lang yung mga points kung saan nag-change ang concavity ng ating function. So, it could be the point where you change from concave up to concave down, or from concave down to concave up. Let's answer this one. We determine the points of inflection and discuss the concavity of this curve. Okay? So, first step, we get the second derivative. Okay? So, if you check, polynomial lang naman yan, no? So, if you check, the second derivative is 12x squared plus 6x minus 6. And factor out natin because we want to get the zeros or the possible points of inflections. So, pag finactor out natin, ito yung kalalabasan. Therefore, the possible points of inflections occur at here, x equals 1/2 and x equals -1. So, katulad ng usual natin na ginagawa, to describe the signs, we make a table of signs for the function we are considering, and in this case, we have f double prime. Okay? And also, lagay din natin yung PPOI sa ating column. We have -1 and 1/2. So, itong table na to, again, very similar siya dun sa table natin kanina sa pagkuha ng relative extrema. Okay? Pero papalitan lang natin siya ng factors ng f double prime. So, first, we get f of x, the functional value of our PPOIs. So, we have f of -1 to be 0 and f of 1/2 to be 0. Okay? So, given na rin sa atin itong table of signs, so I will not discuss it step by step furthermore kasi ilang beses natin itong ginagawa. So, we can move on to our conclusion now. So, saan concave up si f? That would be at the positive signs. So, we have here and here. So, therefore, f of x is concave up in the interval -infinity to -1, union 1/2 to +infinity, and concave down siya dito because it's negative. So, concave down in -1 to 1/2. Moreover, check natin kung ano ang mga points of inflection. So, at x equals -1, the concavity changed from concave up to concave down. So, you have positive to negative. And at x equals 1/2, the graph changed from concave down to concave up. That's negative to positive. Therefore, we conclude that both -1, 0 and 1/2, 0 are the points of inflection. And that ends the first video for our lecture. In the second video, we will discuss curve sketching.